Very much, everyone. I think we have a broad horizon from different states, different background, right? And what I see is all are related one or other way to the environment. They have a different background. So that is what the environment is. I have worked in my career in different projects as a teacher, as a consultant in the government, right? In different places, different projects. India, Australia, Canada, and US. Different background people I have worked. So what I understand is here we have a very good crowd. So I also see there are many faculties, scientists who are pursuing a very great studies in environment, water quality, groundwater, solid waste management, landfill. I also see biosolids. So you are working in the core category. Environment is like that. You need a variety of experts to make it successful. So that is why this course is designed. Right? If you see, this course has a different components, right? So all different components are managed by different stakeholders, right? So all have to work together to make it successful. That is what I see. The very purpose of this course is to understand how this system works in our country. It is easy to say why it is not working. So to understand why it is not working or why we are not at that level, I don't say we are not working. It is working in some place to this very slow speed. But other countries, they are very successful. That is the model I want to present, and you should understand how you can move forward, right? It is not in a comparison, it is to understand. Once you know the best system, then you can, promote with the modification to the current conditions. That is what you will have to do. You not only you have to develop your expertise, you are already contributing, is it? And you also spread this awareness to other people by students or wherever you are working, wherever you have an opportunity to work in different projects, make it work. That is what I all the time I say. You have education, aspiration, but will to contribute and create is very important. You should have a passion to do that. It is not just for the sake of doing something. So that is very important component. One has to develop and keep it forever. That is one. Second part is a hobby is always important. You have to also lead a happy life. You should also enjoy. Once you like, you should enjoy your work. Not only the failures. Failures are the first step for the success. That is what you learn. It cannot be everything successful. But the work towards successful is important. You may achieve some part and next person will carry on. That is how this is the environment. If you see how big it is not a one person. That is why I was trying to tell what are the different stakeholders in this industry. You see the industry people, you see the government, you see the activists, you also see the public participations. You have to work with the different expertise. You have to also borrow some of the expertise from other countries. So all have to work together to make it successful, because the place where you are living right now, we have a limited space source. Also, all the resources are limited. You know, the degradation. We every day we find a new product, new contaminant generates, right? So at the same time, we have a capability to generate the contaminants, but we should also find the solution, how to take care of that. There are certain things which we cannot live without that. But that is okay. At the same time, we should make sure that we should keep our environment, water, air, and soil perfect conditions. At least we should start working towards. So that is what about this course is. So you guys are doing great. I'm very happy to see you all, and your work and your background is just amazing and incredible. So thank you everyone. So this is all about that, and today what I am going to do is I am going to do two tutorials, in the sense I am going to take two case studies. We saw in the lectures different components, how we work together. We will go tomorrow about the treatment side, of course. But today what I have done is I have taken two case studies, means two industries which discharge to the city wastewater. So two case studies just to highlight what was the problem, how it is identified, how it is addressed, what are the resources we spent on that, and how it became successful. So that is what I want to mention about the important steps. We have seen many revelations, this is contamination and all, it is there. But if there is an issue, there is a way to solve it. If you do that, that is what you have to go a step ahead to make a contribution and creation. Once industries are not like that. Industries, if you help them, work with them, many industries step forward. They also want a solution, but they are so busy, sometimes that may not be an intentional. If anybody wants to, one can step forward. I have done cases, success stories like that. Yeah, if they are willing to work, you can step one step forward to help them, give them some time, give them all the help they want, assistance from your side. Then it becomes successful. Then how you feel once the system is not there, and today you have developed the system. This is just unparalleled to anything. If that is the pride you are taking, if you step forward, you can make a change in the system. So that is what this case study about it. So in this, there is a food processing industry in a particular place in our eastern region. I have given some highlights, what it is, to understand. It is a food industry. It operates for the food processing. They do all kind of vegetables, clean it, and make it contaminant free, then pack and sell it to other countries all over the United States, right? So in the food industry, what happens? Large quantity of foodstuffs comes in. Then you have to, there are a system, the process plants which cleans that. Then there are solid generation, lot of solids is generated. In addition to that, what happens? BOD, concentration. So one particular industry was facing issues with the solids. because you have to remove the solids and then discharge. Otherwise, what happens? It will create a problem to the receiving side. There are two components in the receiving side. Cities, what they do is they build a wastewater treatment plant which basically treats domestic wastewater, correct? Then you have a certain industry, some part of the industry, few industry, it depends, you cannot put all the industrial wastewater into the domestic. Certain percent, it has a capability. You can mix certain industrial process water into that domestic wastewater, and that is taken care by the city, correct? You can do to some extent. But in certain places what happens, they have a large number of industries. They cannot accommodate, put everything in the domestic wastewater and treat. There is a capacity. That is why they do industrial wastewater treatment plants separately, where they can put a number of industrial wastewater is pre-treated and then it is treated by the industrial wastewater. That is how exactly you saw yesterday. That is a common effluent treatment plant, how it is called. Before that, when I was here in India, I have worked in the common effluent treatment plant also for different. But it has its own issues, because if it is in a particular place, particular zone, it will be easier for you to track and collect them. But if they are scattered everywhere, it becomes difficult. You have to put more infrastructure, track that. That is what you have seen in the previous lecture, how it is identified, what are the issues, that you have already seen that. So this particular industry, the facility discharge maximum monthly flow of 9.5 MLD. I have converted that. It is 2 mgd. So this volume of wastewater is discharged every day. See, imagine the type of the plant. That is the usually tendency there. They have always a very big, whatever they do, a big plants. So that is easy to manage. That is just a system. That is why most of their stuff is mechanized, right? So 9.5 million liter per day, and maximum daily BOD load is this much, 57,720 kg. That will give you just an understanding the quantum of wastewater, the quality of wastewater, right? So that was discharge. Process water reuse facility, that is, they were discharging it to the city, they were having issues with the treatment. It was a delegated facility, of course. I mentioned we authorize the city to take care of the wastewater which is coming into their treatment plants. So this is a little bit about history, when it was started, because what happens when they started earlier, treatment plants are not built accurately, right? Industry go on expanding. It is a problem with everywhere. But unless somebody given a proper attention, they will not upgrade. So that is why they wanted to expand and make sure that they will take care of the wastewater receiving. Okay. So if you see the system, what happens? They have a system. You can see from the left side, the big trucks will come unload there, then goes to the storage, clean up area, and this is the storage and cooking, pressing. That is the sources of wastewater coming from different processes, right? This is all the wastewater is collected from different processes. Then the dried product is taken out. Then the pre-treatment what you will do? I said when industry discharges to the receiving wastewater treatment plant, they have to pre-treat. So that is why you see remove oil, recycler, skimming, it is taken out. Yesterday you saw little bit of that. At one corner there was a skimming. It has to be removed before it is discharged there. Then settling means it has a solids. When you clean that, it has a lot number of, the volume of solids. That is settling. Then wastewater to the suspended solids here, the stream. Is it? Then this wastewater comes here to this pre-treatment unit. You see, then the different processes takes place. Then the clean water, this goes to the treatment plant. If I show here, you will understand. Process water reclamation facility. This is the flow, solid removal facility, and winter storage and double liner pond. What happens is, treatment system is slightly different. Here it is the climatic condition. In the winter, they have to store the wastewater which is coming out of the system. Because in order to regulate, you cannot just discharge the wastewater as it comes, because you need a regular flow. When the receiving treatment plant always specifies how much wastewater we can accommodate. Is it? That is what I was telling you. They have a lot of limitation about the flow, about the different parameters what they discharge. So that is why they build a huge pond where the wastewater is first discharged there. Then that is a buffer, right? Then they can regulate the flow. In the meanwhile, what happens? That also act as a settling tank. When you are collecting the wastewater, you are giving little bit treatment. If it is a pH is high, if pH is normal, no need to do that. You cannot, when you are discharging to the treatment plant, one thing we should make sure that you are not doubling the cost of the treatment. It is not necessary to treat here also, and you have to treat there also. No, you have to give that privilege to the industries also, right? You just cannot put everything there. If the receiving side is capable of treating, then why you want to treat it here? Treat at one place only, if it is not causing any harm, right? So that is your determination, how we will do that. So what happens? It is collected in the pond. When you are collecting the wastewater in the big pond, it must be double liner, geomembrane liners. They are in terms of 10 acres, 5 acres, such a big ponds, right? Double liners. I see some of you are already working in the landfill, leachate collection, I heard, right? If you are collecting the leachate from the landfill, what happens? It has to be double liner, geomembrane. If it is a single liner, what happens? The regulation says you have to have a groundwater monitoring. If there is a leakage, if it is entering the system, it may go to the groundwater. Then he said, no, it is a correct system. It is possible to do it one liner. No. If there is a leakage, how we will prove? Then you have to monitor the groundwaters. You have to always prove that our groundwater contamination is not going up. That is the system. Why? That is the rule. Then if you want to avoid a groundwater contamination or groundwater monitoring, groundwater monitoring is a big job. Some people have worked in the groundwater, right? It is a big job. You have to have a different monitoring wells around, and you have to take a sample. You have to make sure that it is not leaking anywhere. It is not causing contamination. That is a big job. So if it is a double liner, then they can avoid that groundwater system, right? You have a second layer protection. Then if any leakage is there in between, there is a system which shows there is a leakage, that the level goes up there. It is connected to a monitoring system. So the level goes up there, then they can understand there is a leakage. Then there is a way fix. So you have a double liner protection. Then you don't need a groundwater. That is why it says that the treated wastewater is put to a double liner system. Then the treated wastewater, how it is treated? All the suspended solids are removed. This is not that contaminated. If the BOD, biochemical oxygen demand, what you say, 5 days BOD we do, right? So if that BOD is about 300, 400 or maybe 800, then the receiving wastewater treatment plant can take care. Because what happens, domestic wastewater, usually they are built for the domestic wastewater, where the BOD 5 is around 300, correct? If you have to give a little privilege for these industries, if it is 500, 600, 700 in case of food processing industries, then they say that you can discharge, because when they mix it with the domestic wastewater, their treatment plant is manageable. So how it is helpful? It is helpful to the city also. These industries, you see, they are taking care of their treatment. They pay a lot of money to them. See, this is how the funding to the system. That is why it is always work for the cities and industries together. Right? So they get a lot of funding. Cities, how they will do, how it will build the treatment plant. It collects the money from the residents, and that money they build the infrastructure. But if the money funding is coming from the treatment plant or the industries, other resources, it is well and good for them. They can have a better system. If we have enough funding, regular funding, we can have a better system, right? So that is how the collaboration works there. So agreement will be there in that, even when they are discharging, this is the volume of wastewater we are taking. Then what is our job there? Regulator. If it is a delegated, city is delegated, then what happens? City will issue the authorization for them. Then the city will monitor them. How much is the volume they are sending? How they are taking care of solids? Are there any violations in the BOD? Are there any leakage? Is there any leakage? How you will say? There is a leak detection test, which they will have to submit a report that it is not entering the groundwater, right? So that is how it is a win-win situation. Why I am giving this example is, the industry and the city treatment plant work together. See how the financing is done, right? Here if we work in a two different direction, nothing will happen. They take care of them, and the city will run partially here and there. People won't pay tax. They won't be having the resource, right? So this is how kind of an industry and city collaboration. Instead of building one plant, you build a big plant, right? If it is a 5 MLD, you build 10 MLD. Big plant are easy to manage. You can have a lot of resources. You can also help industries. You will have a good collaboration. You can use the latest technology. This is how the system works, right? So this system has to be come to the existence here. That is what the very purpose of this. That is why I am giving example how it becomes successful, right? So when we say groundwater monitoring, what we observe, which is the major contaminant, is the TDS, the total dissolved solids. Dissolved solid is a very important component. That is why your groundwater, the characteristic of wastewater, groundwater changes. We have a different groundwater regulations also. Once the discharge is on the land, then the groundwater monitoring comes into picture. You have to be more careful. When you are discharging it to the river fisheries, there are some people who were working on the fishery sites, right? So there are a lot of strict regulations also there. It is not only the Department of Environment, and also the fishery people will come into picture whether you are really taking care of the wastewater, because fishery standards are much higher, right? So that is how the collaboration start works. The money is generated and the system works, right? And you are also helping the industry, right? And you are also you are making sure that they are not doing anything which is wrong. It is a win-win situation, and the government also monitors that. That means we monitor them. We also observe. We take the report. We see the sampling. They have to send every month the report, every month, and daily observation. See how tight it is. There is no chance of any movement here and there. Every day they will have to have measurements, weekly parameter measurements, and monthly or quarterly, maybe some contaminant if you observe, they have to monitor that, and yearly they have to submit a report. See, where is the chance there? So chances will reduce, the system will become more efficient. That is how it has to be managed. If we say that some industry is discharging, there is no regulation, but how long it is going to go, right? That is what I wanted to show. There is a system which can be worked out. So there should be some guidelines, regulations. That is what all people have to work together. That is the intent of this case study. If you see here, what is this pre-treatment system? I have put some line diagram. So this is the city, right? They have a treatment plant. There are many industries, 5-6 industries. What they will say? Okay, we will fund the city treatment plant, and they also take care of their residential wastewater. They can all discharge there. They can build a big treatment plant, and they can take care of it. Both are happy, right? Government is also happy because they are doing it. And if there is any issue, then we interfere there. The city, what happens? See, the city is capable of doing that, then we delegate. If they have to also step forward, if they have a funding, people who are working, there is a large team which works on that. It is not a one-person job. They have equally a big team which can do all the sampling, measurements, reporting, enforcement, all, and a lab analysis. Is it? So that is done here, city. If the city is not delegated, then we do directly, right? And if we delegate them, still we monitor. I oversee. There are reasons which I oversee entirely, and I also help the other areas how this delegation should be done. This is how. See, different industries, processing plant, discharge it to city wastewater treatment plant. It may be domestic, partially. There are certain situations, if there are 10-15 industries, then city says, okay, we will build another treatment plant. We will build specifically for your industry, and we will manage, right? So they can build. I have an example. This particular place, they have both the city municipal wastewater treatment plant, that is the domestic wastewater treatment plant, and they also have industrial wastewater treatment plant. So what they do, there are 10 industries, we put 2 there, and rest of them all we will be putting in this industrial wastewater. That is how they balance. They get a lot of funding also. There is a big team which monitors. I will sometime, there is a video also, I will show you how successful it became, right? So this is how, what you will do, when different industries are there discharging, you will build an equalization tank first, because some may be seasonally, they will do just 6 months in a year, right? And some will do continuously, some will do few days in a month and few days off. So it is not consistent. To have a consistent flow, right? You cannot do that in the season you discharge a large sum of wastewater, and in certain days you are not doing anything. See, it should be your treatment plant which is built has two important components. One is the hydraulic loading, another is the organic loading. You should balance both of them and then you discharge, right? So that is how, in order to achieve both of them, we do in a big equalization. This is the small one. They are in 10-15 acres, multiple ponds, 3-4 ponds connected. I will show you some pictures. I think I may be having. So those ponds, they have a big buffer. They can draw the wastewater uniformly without affecting their main central system. This is all the receiving wastewater treatment plant is managed online. You can see how the wastewater is coming, what are the sampling points, what are the analysis. Daily it is a big job of monitoring all the stuff. And all the analysis data, the analysis has to be done by an accredited lab. When it is accredited, they have a responsibility. They just cannot do anything, right? They are monitored, and we decide where it has to be measured, when it has to be measured. This is all given in that authorization, which we call permit or an authorization, right? So it is all mentioned there. So these are the some conditions which put in the authorization, right? That is for the measurements. But in case of what happens, how if it is as good as storing a big, small dam, storage dam, then if it is too big, then the dam regulations are also there. If a embankment collapses, what measurements you have, what actions you have, what is the spill plan in your plant, what is the sludge, where your sludge goes, everything should be documented and it is open. Where if we have an authorization, then the person can go and monitor, see, ask for any information which is required. No one can deny, right? So that is how this is a win-win situation is created here, right? Then if you see the problems and actions, I've seen over the years plant, expands and excess building of solids. That was the problem, right? Then the primary source of solids in the effluent was due to inadequate volume of the base. They are called mud base, right? So if your treatment is inadequate, then what happens? There is a problem. This is the particular industry. There are number of industry. One industry I have taken as an example. This was having a problem with solids because their treatment system was small. Is it? Settling chamber was small. If it is small, then the flow, what happens? There is a less detention time. When the detention time is not sufficient, suspended particles won't settle. It will just go with the flow and it will cause a problem there, right? So that is why it is important to have a sufficient detention time. That is why the engineering evaluation is done. What should be the size, depth and all that is a common. A professional engineer will design and make sure that it is consistent and consolidated, all the information in that. So there is a screen, all the floating material, that is the normal treatment plant you have seen there, and we will also see more of this information in the biological treatment. So it has a rotary screen, existing base means that is the settling tanks, and it was discharged directly. This was the problem, right? Then we said no, this is not going to work because This problem will not be solved unless you spend money on the treatment unit. You should need big ponds where the proper settling is achieved and solids are removed and BOD is reduced. How you can reduce BOD? You can reduce by providing an aerators, right? Right. So this was the problem, and then took it this one. After the engineering evaluation, the efforts were made to stakeholders bring all the people at one place, right? What is the problem? Because you have to bring the receiving end and the discharging end, people around there and the regulator all together and find out the solution. Then consultants will also be there. So then this is how the solid removal system is built, and the issue which was with the solid removal is solved. What is the outcome? They build a new treatment plants. Old treatment plant, they refurbished. They build a new treatment plant. Then they added the aerators also to reduce the BOD, that is the DAP system, dissolved air flotation. You have seen air flotation there, right? Rotaries were there in the wastewater treatment plant. Here also they put a DAP system. Once you put the DAP system, the oxygen content is increased, the BOD is reduced. That is how you will learn more about this in the biological system, right? So in this, the DAP system will reduce the BOD. I will show you the picture of that. So that is how the BOD and suspended solids issues are solved, right? See, then another important thing is there was a big pond there. You collect the water from the process plant, then if your system is not sufficient, that water will go somewhere. There was a stormwater pond. This wastewater was entering. You have seen in the morning some example. If your sewer system is just breaks like that, it will go enter everywhere. Even it may enter a lake around area. So that is how it happens. Made sure that no leakage from this industry goes to the pond. So pond is protected, correct? So what were the problems? The solid problems is solved because they built a new settling tanks, right? Increase proper detention and the engineering design was done on that. Then also you put a DAP system into place where you reduce the BOD also, and you made sure that this wastewater is not entering the big pond there, which is close by. So all the issues have been done. So if you see, rebuilt rotary screen and DAP system, then it went to the receiving wastewater treatment plant. You can see these are the new ponds built like that. See, this is the DAP system. This is the pond which was just filled with wastewater earlier, and now how it became very clean and neat. So these are the success stories. All the important issues related with the industry working together, these issues are solved. So this is how this system is done, right? This is about the first case study. If you have any question on this, go ahead. Right?
Any question?
You can also share if any other specific issue you have worked, there was a problem and there is solved, right? You can also share. There is no. So this is how the system works. If there is an issue, how you will solve? You have to solve step by step. Work, bring all the stakeholders together. Understand the issue around them. Give them a time. They also will step forward. Otherwise, what happens if you put for an industry, if it is producing large quantity of wastewater, if you put certain amount of fine, it's of no use, right? I have worked in the industry. Per day production was $2 million. If you put a $10,000, is nothing for them, right? So that is how. That is not your main aim. Main aim is to solve the issue forever. See, this problem is solved at all. This problem is solved forever, right? This is how there is an industry institute partnership, right? So this is how the system works. Okay, if you do not have any questions on this, that is fine. Thank you on this. Two-minutes break. Okay. So we are at right time. We completed just 5 minutes or 4 minutes before 4. There is a 5 minutes break. We will see another case study, right? You can take a 5 minutes break if you don't have a question. Then I will go with as a second tutorial.